So we're going to start this next part of our unit off. If you look at Unit 2, the name of the unit is Solving Equations and Inequalities. So for the last 2 weeks, we've been solving equations, all different crazy kinds of equations with parentheses and distributing and variables on both sides. But now, and every time you got an answer, the answer was x equals 5 or x equal 2, right? Well, we're going to get to some inequalities today, and the answer isn't going to equal a number. It's going to be it's going to be different from that. So let's talk about these little symbols right here. And the first time you really saw these symbols, okay? And actually, let's go back before that even. Let's talk about the first time you even understood what this concept meant. And it was probably back to kindergarten, where as a kindergartner, they gave you different shapes. They gave you 2 groups of shapes, and they said, circle the group that has more, right? Okay? So as a kindergartner, you counted 1, 2, 3, 1, 2, 3, and hopefully you knew that 3 is more than 2, so you circled that group, okay? So even as young as 5, they're starting to introduce the concept of greater than to you. And then maybe the next year that you were in first grade, they replaced the actual numbers of with the actual amounts with numbers. And teaching number sense is like, you have to understand what that means. So to a kindergartner, if they were to say, which number's bigger, they may think, oh, 3 is a little bit bigger. Or they might say they're the same size. They're looking at the size of the number that's written and not the actual meaning and the value behind it. So until you develop that number sense, you have to know that the number 3 represents more than the number 2 does. And they're not equal to each other, right? 3 does not equal 2, okay? So after they say, okay, they're not equal to each other, then what are they to each other? And that's when they introduce these symbols to you. And I don't care who you are, where you went to school, your teacher probably taught you the inequality symbol as the alligator mouth, right? And the alligator mouth is hungry and he eats the bigger amount, so that the bigger number is, and some teachers may even, put a little teeth on it, or maybe some of them made it a Pac-Man. But I don't care who you are to this day. I'm the teacher who's been teaching math for a while, and that's how I remember it. Put the mouth towards the bigger, okay, or the greater amount. So those are kind of the background and the history that got us up to what an inequality really is. It means it's not equal to. So if it's not equal to something, then that means it's either greater than it or less than it, right? Those are your other 2 choices. So let's kind of just go ahead and write these, because I'm going to introduce 2 more symbols to you. You may have learned these last year with Mr. Meeks. So if that's the case, then that's great. These are just going to be a review for you. So there are really 4 symbols that we are going to work with this year in 8th grade algebra. And these ones may or may not be new to you. So, and here's the other tricky part to think about. When you're looking at this symbol, it's easy to say what this symbol is here when you see the numbers. But when there's no numbers, there's still a certain way that you have to say that. It doesn't depend on where the numbers are. Every single time you read this symbol, we'll start with this one because it's easier here. Every single time you read that symbol, you say the words is less than. And the reason and the way that you can kind of remember that is if you tilt it, it kind of looks like an L, right? So every time you see that symbol, they mean to tell you that you're saying is less than. All right? And then, do you know what this means? Did you learn this last year? Okay, good. So this is the is less than or equal to. And we're going to talk about what that means. So then if this is the is less than or equal to, this one up here is the is greater than, with this one being the is greater than or equal to. And we're going to talk about what that means. So if I were to give you this here and ask you, is that true or false? It's false, right? 3 is not greater than 3. 3 is the same as 3. So that would be false. However, if I put that line underneath it, does that kind of satisfy that inequality now? Is this true now? Yes. Because let's talk about this word or. Or means pick one. It doesn't mean both has to be true, correct? We're going to learn that later in the week when we talk about and or statements. But and means both have to be true, or means only one. So it's not greater than 3, but isn't 3 equal to 3? All right? So then technically, could this symbol also be true? Right. So the greater than or the less than symbol doesn't apply here, but it's the equal sign that kind of saves it. So we just kind of want to get our mind wrapped around these whole greater than or less than signs. So we're going to describe some sets of numbers right now. And we're going to describe it in 3 different ways. 1, 2, 3. So I'm going to give you an inequality, and the first way you're going to describe it is with words, meaning what words come out of your mouth when you read that inequality. Then I'm going to ask you to list what numbers would fall in that set. And then I'm going to ask you to finally graph it on a number line. When you hear graph, you think coordinate plane and plotting points, and it's not that at all. So let's start you off with the inequality, that one. So let's words, list, number line. Okay? So it's almost like, you guys have Spanish translative. Mrs. Meeks puts a sentence on the board in Spanish and asks you to translate it into English. I'm asking you to translate it from math into English. What comes out of your mouth when you see that? X is greater than 5. And that's really just what the first step is. Are you able to even say that and identify what symbol that is? So then the second one is a list, which means now, and we use a little bracket or a brace rather when we talk about sets of numbers. So this set of numbers that satisfies this inequality starts at what number? Yeah, 6, okay? It does start at 6. And then it's kind of tricky because some people may say, well, there's a whole lot of numbers in between 5 and 6, right? So it's kind of weird because we start at 6 and we say 6, 7, 8, ... Because the ... means it goes on and on and on forever in the right-hand direction. A number line never ends, right? It goes on for an infinite amount, which is a really hard concept to grasp or put your mind around. But so I don't start at 5 because I would say, well, it's kind of like, where do you stop? 5.0, 5.01, 5.001, 5.1, 5.2, 5.112. Like, there's an infinite number of numbers in between 5 and 6. So when we do our list, we go with just the whole numbers. So this list is a perfect set to describe that set of numbers. So now we're going to talk about your number line. And here's how your number line is going to work. The first thing you're going to do is always put the number in the problem on your number line. That's the number that we want to know about in terms of what is greater than or less than that. And then there's 2 other things I want you to do, and that's going to sound really simple, but it happened in first hour. And you would be amazed. I want you to tell me on what side of 5 0 should be. So where is 0 in relation to 5? It's off to the left, right? And it sounds so simple, but it actually happened first hour. Somebody thought it was over here. Okay? I think they just had it backwards. I may have said, where is 5 in relation to 0? And he said, to the right, which is true. But I think the question was, where is 0 in relation to 5? So, and then the next thing that I want you to do is put 2 numbers, one on either side of the number you're talking about, which 4 is here and 6 is here. So make sure your number line actually makes sense. If you number your number line wrong, your arrow's going to go in the wrong direction. So now what I'm asking you to do is you're always going to start with a circle around the number in question. And now I want you to shade. You could highlight, you could shade with your pencil. So where on the number line are the numbers greater than 5? Meaning 6, 7, and 8. That's why that's kind of helpful. Because I'm going to shade to the right, because that's where the numbers are greater than 5. So these words match that. This set of numbers satisfies that inequality, and this graph satisfies that inequality. Meaning, if it's covered in blue highlighter, then it is a set, or it is a solution to this set. Meaning, if I put 8 here, is 8 greater than 5? Yes. If I put 6 here, is 6 greater than 5? Yes. If I put 5 here, is 5 greater than 5? No. So we have to have a very special way of symbolizing how that's not a part of it. So do you see how I have that right there? And it has to start at 5, because guess what? I had somebody ask, why didn't it just start at 6? If you started your list at 6, why not start your graph at 6? And what would your answer for that be? Avery? Yeah, because there's a whole lot of numbers in between 5 and 6. There's an infinite number of numbers, and I have to show that somehow. So I start at 5, and I cover those numbers, but I don't start it with the list. Okay, good. Let's take this and see how this changes things. So me just adding in this one little extra line there, how does that change my words, my list, my number line? Doesn't change the words much. It just says X is greater than or equal to 5 now. I'm just kind of abbreviating and saving some time. Which means now that, how does that change my list? How does that change the set of numbers that belongs here? I don't start with 6 anymore, do I? I can start with what now? 5. 5 can be included in that list now, in that set of numbers, where it wasn't before. Do you see the difference? And now let's take a look at how that affects our number line. 0 is still here, 4 is still here. So I'm going to start with my circle. I know all the numbers to the right are greater than 5, but this time what can I do to symbolize that? All right, now 5 is a part of this solution. Here, shade it in, okay? So I can color that in and still every number to the right. So do you see the difference between X is greater than 5, but X is greater than or equal to 5? You remember this from last year? Okay, so you did the actual graphing of them as well? Okay, was that towards the end of the year there? Okay, yeah, because sometimes we don't have enough time and there's either no time for it or we're rushed through it. So I'm glad that you had time for that. Okay, things kind of get a little crazy when we start to talk about negatives. And this is where your number sense and your familiarity with the number line really comes into play. So first, X is less than -3. And so I really want you to see this number line right here underneath the projector, the overhead screen here. That's why I bought this, because kids are having a really hard time looking at, what number. Or, you know what? Look on the ground. I have a coordinate plane axis is taped to the ground. So if you're at -1, what number would be directly to the left of that? -2, and so on, right? So directly to the left of it. So if I'm asking you to tell me all the numbers that are less than -3, what's the first whole number on the number line that would satisfy this? Meaning you're wanting to get farther away from 0. I want you to think of left means less. Go ahead. -4. Good. -4, then -5, then -6, ... So those numbers in that solution set satisfy that inequality. Because if I put a -4 there, -4 is less than -3, you're good. So doing your number line might be a little bit of a challenge, because where is 0 in relation to -3? 0 is always to the right of your negative numbers. What number would go in front of and behind it? I would, if I were you, if you're confused at all, just start at 0 and think to yourself, -1, -2. So this is -2, this is -4. And now I want to ask myself, can my solution set include -3? No, there's no equal sign up here, and less than means to the left. And here's how this can help you if you number your number line appropriately. You know that the -4 is in your solution set, so it needs to be covered, correct? Okay, good so far? All right, the only other thing that may be confusing is this. When the inequality sign has the number first and then the variable. So this means, and here's the way to think about this. 4 is greater than 3, right? Which means that 3 is what compared to 4? less than. If 4 is greater than 3, that means that 3 is less than 4. You have two options at this point. You want to know my advice to you? Turn it around. Because if you put 8 is greater than x, you have the greater than symbol in your head, and you're thinking greater than, and you're going to probably tell me 9, 10, and 11, aren't you? But if 8 is greater than x, that really means that x is less than 8, and 9, 10, and 11 is not less than 8. So my advice, switch it around, get it to where the variable is first, make yourself comfortable with that, and then go from there. So now that we have it switched around, then you can go ahead and tell me that x is less than 8, which means x could equal 7, 6, 5, or anything in that direction, which means your graph can include the number 8, and then your 7 is here, and your 9 is there. And now you know you're not going to shade to the right, even though that symbol's going to the right. Yeah, having the variable on the left is your best bet. And it's really tricky when you involve one like this. -6. I mean, talk about now you throw in, oh my gosh, I have a less than symbol in my head, and now I have a -2 to kind of consider. So, off the top of your head, are you able to easily look at that and go, oh, boom, duh, that's 7, 8, 9? Anybody? You got to really think about it, don't you? So let's take a little bit of the hard work out. If -6 is less than a, that must mean that a is greater than -6. Now we're a little bit easier. And I want you to picture standing at -6 on this number line on my floor. And if you want to get greater than -6, you want to get closer to 0. So the first that number that a can be, let's do this. Because I want it now to include -6. What's the next number it can include? To get greater than -6? -5, -4, ... You got it? Okay.